Okay, so Math at Work 10, this is the video lesson for calculating the surface area of cylinders and cones. Alright, so just a couple of things to refresh as we go through this. One, when we talk about surface area, we are talking about the number of square units needed to completely cover a three-dimensional object. Alright, so we've already done that with our previous lesson on surface area of prisms and cubes. Okay. What we're going to focus on today is a right cylinder. Okay, so this is a three-dimensional object with just two parallel circular bases, right? So a circle on the bottom, a circle directly over top of it, and then just a space in between, right? And then we'll also be talking about a right cone, where again what you have is just a circular base. Okay, not all cones have circular bases, but for our purposes we will just be talking about circular bases, and its apex, or like the vertex or the point of the cone, is directly above the center, right? So it's not slanted, it's just a perfectly straight cone, okay? The other thing we'll talk about a few times is we'll just be talking about a lateral surface, right? So total surface area is the sum of all of the faces or all of the surfaces to completely cover an object. But sometimes you'll only be asked to find the lateral surface of something, which is just like the curved or slanted area of the 3D object, right? So kind of like the around part, not like a flat base, okay? So it would be just ignoring the base or the top, but it's just like what's the area of just kind of the around part, okay? And then again, just a refresher, when we talk about a net, we are talking about just like the flat two-dimensional representation of a 3D object. Like if you were to take, try and make that shape just out of a flat piece of paper, what shape would you need to cut out to be able to fold and then have it, pushed together, okay? So like I said, this would be an example of our cylinder, right, our right cylinder. So just again, you can see a circle on the top, there'd be a circle there on the bottom, and then this shape here is actually a rectangle, right? So when you unfold this, this is the net here. So again, you've got two circles, which would kind of fold up, up, and then this rectangle just kind of folds all the way around, okay? So because of that, the length of this rectangle here needs to be long enough to go all the way around the circle. Okay, so you might remember when we did our lesson on perimeters and circumference, right? The circumference is the distance going all the way around the circle, which means that this length of this rectangle here would be the same as whatever the circumference of the circle is. Right, so remember your circumference is equal to pi times the diameter, or 2 times the radius times pi, either or. Right, and then this 3 meters here would correspond to this height here, okay? With a cone, again, what you're seeing here is a flat circular base, and then this would be called the lateral surface area here, right, just the around part of the cone. And if we go back to the cylinder, it's this rectangle, right, the around part of the cylinder that would be considered the lateral surface area, okay? With the cone, again, what you have is you have that circular base, and then depending on the height or the width of that particular cone, this lateral surface will look like a partial circle, right? Sometimes it'll be, a little bit more here, and then like the opening's a little bit less. Sometimes it'll be even more flat, right? It depends on how big it is, but it's essentially this kind of fraction of a circle, because what's going to happen is that that's all going to curve together to be able to go around that base, right? And then these edges here, what we call the slant height, right? So there's a difference between the slant height and the vertical height in a cone. Your vertical height goes from the tip straight down, as if you're going like through the middle of it, whereas the slanted height would be as if you were measuring it from the bottom and then going on an angle. Okay, so surface area formulas always use the slant height. So like if it was a three-dimensional object, you'd have to kind of lay like your ruler along with the angle of the cone in order to be able to measure that slant height. Okay. So our methods on how we calculate surface area are kind of similar to what we did before, right? You can either draw the net and then take a look at what each of the faces and surfaces are, and then calculate the area of those, okay? That one for the cone is definitely really tricky, right? The cylinder's not so bad, because we had circles, we know how to find the area of circles, and we had a rectangle, and we know how to find the area of a rectangle. This one's a bit interesting, right? We don't know exactly how we're going to calculate this funky part of the circle shape, right? So for this one, we will in fact use a formula, okay? But for the cylinders, it's pretty straightforward. You just kind of draw your net, okay? Again, with cylinders and cones, they actually have really standard surface area formulas. So you remember our last lesson, we did the one on triangular prisms. It was like, well, there's not really a set formula. You just have to know you got to find the area of all the sides. Okay? with cylinders and cones, there's a set formula you can use all the time. Just make sure that you, again, understand what parts of the formula mean what, because there are going to be times, even in this lesson when we do some examples, where not all the faces are being used, right? So maybe you're just trying to find the lateral surface, so you need to make sure you're subtracting the area of the base. Or with a cylinder, maybe it's an open something, right? And you don't have a top, so you don't need 2 circles, you only need 1, right? So how does that affect your formula? Okay, so just be aware of that as we go through. Okay, so again, kind of going back to our, we'll focus on the cylinder first, right? So the most common cylinder I think that everyone can relate to is just like a basic soup can, right? Can of tomato soup or a can of chicken noodle soup, or pick your favorite soup, right? So if you talk about like all the faces there, you've got 2 identical circles, right? One on the top, one on the bottom, and you have a lateral surface, right? That would be the label wraparound, okay? If you take the label off the can, that's going to create a rectangle. Okay, and I'm just actually gone to grab my own can here, right? So, I mean, if we're looking at just this basic can of soup, right? There's your cylinder. You've got a flat circle on the top. You've got a flat circle on the bottom. And if we were to peel that label right off, right? You can find the peel now, right? I'm not actually going to do that. But if we were to peel that all off, it'd just be a flat rectangle that goes all the way around, right? And again, like I was mentioning before, the length of that rectangle needs to be able to go all the way around the can, right? So the length of the rectangle here has to be the same as the circumference of your circle, okay? And then the height of the can would be like the height of the rectangle part, okay? So what you end up doing is when you're calculating surface area of a cylinder, you've got 2 circles, right? So remember your area of your circle is pi r squared. So pi r squared plus another pi r squared, or just pi r squared times 2, plus the area of this big rectangle, right? Which would be the circumference multiplied by the height, okay? So go back here, right? Putting that formula together, this 2 pi r squared here is the area of the 2 circles, and then this 2 pi r h is that area of the rectangle, right? Where what you have is that this 2 pi r h just right here, that's the circumference, right? So pi times d, or 2 times the radius times pi, there's your circumference multiplied by your height. Okay, so there's the rectangle, and then there's the 2 circles. So like I was mentioning, is if you were dealing with an open cylinder and you don't need both of these, you could, instead of having 2, just have 1 pi r squared. Okay? With a cone, again, you do have the circle that's on the bottom, and then like I said, you kind of have this part circle that remains, right? So because it's partially circular, you still do see that there's a pi as part of that formula. Okay? So you've got your single circle, there's your pi r squared, and then this is what we call the lateral surface, right, the round part, and it's pi times the radius times the slant height. And again, just remember that there's a difference there between what the slant height is and the vertical height. Okay, so in this lesson and in the questions I've given you, I'll always give you information about the slant height, not the vertical height. Okay, so there we go. All right, so let's get into some examples. So for this first one, we're just going to find the surface area of a cylinder with a radius of 3 inches and a height of 9. All right, so let's do that. So I would potentially just draw that shape first, right? We have a cylinder, right? Looks like that. We've been told that it has a radius of 3 inches. So remember, the radius is the distance from the center to the side of the circle. So that has a value of 3 inches, and then it had a height of 9 inches. There's no slant height on a cylinder, it's just straight up and down, okay? So again, you can think about the net aspect of it, right, where you have a circle, and then you have that rectangle, and then you have another circle here, right? And you could think about finding the area of this circle, right, where that radius is 3 inches and that radius is 3 inches. This height here would be the 9 inches, and this length would be the circumference, right? Where you'd say, okay, the circumference is equal to 2 times pi times the radius, so it's 2 times pi times 3 inches, right? And then you'd have to multiply that by the 9 in order to get that, okay? Or if you like the formula better, you can just say that the surface area is equal to 2 circles, so 2 times pi r squared, plus the area of the rectangle, which is 2 pi r, right? That circumference, times the height. Right, and then you're just plugging in values. So then that becomes 2 times pi times the radius, which is 3 inches squared, plus 2 times pi times the radius of 3 inches times the height of 9 inches. Okay, and then we can just calculate those sections there, where we can go 2 times pi times 3 squared, and this gives us a value of 56.55 inches squared, and then 2 times pi times 3 times 9, which is 169.65 inches squared, and then we can add those together. So 56.55 plus 169.65, and we get 226.2 square inches, right? So again, this part represents the 2 circles, and this part represents the lateral surface area, right? The around part, the rectangular part, and then that's our total surface area of 226.2 square inches. Okay. Yeah, it didn't give us specifics, so yeah, so there we go. Okay, so in this example, we'll try and make it more of an application here. So in this one, for this year's sewing project, Emma wants to design the canvas liner for a laundry hamper, right? So if you think about a laundry hamper and you just want to have the canvas that goes on the inside, right, of just like maybe a wicker basket or something. So she chooses a cylindrical hamper and wants to make the liner 23 inches high with a diameter of 17 inches. Okay, Emma wants to calculate the total amount of canvas, right? She's going to have to go and measure out how much she's going to need to be able to sew it together to put it inside the laundry hamper. She wants to calculate the total amount of canvas to the nearest square foot. Okay, so one of the things that you might want to consider here, and I guess for the sake of questions, I wouldn't necessarily mark you wrong or anything, but I would tell you to kind of consider the fact that we are in fact sewing something here. And if we're trying to sew something together, we need a little bit of an overlap. So even though we're being asked to create, she wants to have this liner where the diameter is only 17 inches and the height is 23, right? Even though that's kind of the conditions we've been given, well, when she's actually going to go do this sewing project, she should have extra space on each of these sides as well as extra space on these sides to be able to do some sewing, right? So what you'd end up needing to do is, for the sake of argument, let's add a 1/2 inch to each side, right? So if we add a 1/2 inch over here and we add a 1/2 inch over here, our diameter now becomes, better marker, if we add the 1/2 inch each side, we now have a diameter of 18 inches. Okay, that's our diameter. And again, if we add the 1/2 inch on each side down here and up here, right, add a half, we get a height that actually turns into 24 inches, right? 1/2 inch on each side. This is now our new height, right? Because that's the actual amount of canvas that she's going to want to need, okay? So the other thing to keep in mind in this scenario is that if we're making a laundry hamper, we need a space, we need an opening, right? And this liner is going on the inside. We want the liner to cover the bottom, so we will need a circular bottom, and we want it to cover everything around. But we want it to be open at the top because we want to actually be able to put clothes in it. So in this case, if we were going to go and use a net, right, well, we need the rectangular part, right, which we've said, okay, we're going to give ourselves a little bit of extra leeway and call that height 24 inches, right? And then we've said, okay, well, for the circumference, it would be pi times the diameter. So pi times, again, we're adding in those extra 1/2 inches, so pi times 18 inches there, okay? So that would be the around part, and then we would need to be able to sew it down to the bottom of the canvas here. Right, and again, that's going to be your circle that has a diameter of 18 inches, okay? So even if you're just visualizing that, but then you still want to use the formula here would, instead of being 2 pi r squared, would just be 1 pi r squared, because we're only dealing with one circle instead of 2. So it'd be pi r squared plus our circumference times our height, or 2 times pi times the radius, or the circumference times the height. Right, so I can say circumference times height, or we can just call it circumference, which is 2 pi r times the height there. Okay, So in doing that, we realized that that 18 inches was the diameter. In order to use our formula, we need the radius, so we need to cut this in half. So if we divide that by 2, 18 divided by 2 is 9 inches. So 9 inches becomes our radius. So our surface area is now pi times 9 inches squared plus 2 times pi times the radius of 9 inches times the height of 24. Sorry about that being a little bit small, but let's figure that out. Okay, so we can do pi times 9 squared. So that's 254.5 square inches. And then the lateral part, 2 times pi times 9 times 24, that's 1357.2 square inches. So we add those together, 254.5 plus 1357.2, and we have a surface area now of 1611.7 square inches. Okay. However, we typically don't buy fabric or measure fabric in square inches, especially dealing with something this large. We want to do this in square feet. And if you go back and take a look at the question, it does in fact ask you to calculate the total amount of canvas to the nearest square foot. Okay, so that would mean having to do a conversion now, right? So we go back to that lesson that we've done now multiple times about converting with area measurements, meaning because it's two-dimensional, you have to multiply by the conversion factor twice. So I would take my 1611.7 square inches. The conversion between inches and feet is that there are 12 inches in 1 foot. What I want was on the top, 1 foot over 12 inches. And then I do this a second time in order to get rid of the squared, right? Because it's two dimensions, so I need to do this twice. So I can take my 1611.7, divide it by 12, and then divide it by 12 again. And this gives me a value of 11.19 square feet, right? So she's approximately 11 square feet, but if you're actually going to buy this at the store, we would want to buy 12 square feet in order to be able to cut that up, right? But we need closer to 11, okay? All right. All right, and then once again, your answers are typed up there, right? So again, you see that she needs a little more than the 11 square feet of canvas for the liner. Same thing here if you just use the formula. All right, let's switch to cones. Okay, so like I said, with cones, you've got a single circle and then a lateral surface area. Okay, so with this one, like I said, it's a little more challenging to try and draw the net. So with cones, we're really just going to stick to the formula. Formula being pi r squared plus pi r s. Okay, so s being the slant height. So if I look at this one, I clearly see that I have a circle with a radius of 1 meter. Excuse me. And I have this slanted height of 3 meters. Okay, so we're just trying to find the surface area. So if we do that, right, again, I just want to make a point here that your surface area, your slant height and your vertical height are not going to be the same, right? So if you were to actually like think of this as kind of, you know, the straight middle part of your cone, right? My arms are, you know, for the most part, the same length, right? Elbow to finger. And then if this is going straight up, right? These are both representing the vertical height. If I then move one of my arms out, right? If I want it to stay at the same base, right down where my elbows are, what's going to happen is that my fingers are going to kind of go down a little bit. Okay, so what you end up having to happen is that if you wanted this to stay up to the top, but then also have this reach the same bottom level as well, you would end up having to have a longer value. So your slant height will always be a little bit longer than your vertical height. Okay, so just keep that in mind. All right, so going back to the actual surface area of the cone, right, what we have is we have this formula of a single circle pi r squared plus that lateral pi r s. Okay, we were given in that question based on looking on the diagram, the radius was 1 meter. So pi times 1 meter squared plus pi times the radius of 1 meter times the slant height of 3 meters. Right? So then you just multiply these together. Pi times 1 squared, which would be 3.14 meters squared. And then pi times 1 times 3, which is 9.425 meters squared. Right, and then you can add those together, 3.14 plus 9.425, and you get 12.565 meters squared. Did the question ask for a particular unit? Nearest tenth, so that's 1 decimal place. So that would mean I would round this 12.565, I'd round it up to 12.6. Right? The other thing you could potentially do is instead of rounding here, you could do pi times 1 squared. Do it all in one step in your calculator. Right? So pi times 1 squared plus pi times 1 times 3. And then you get 12.566. And again, that would round up to 12.6 meters squared. Okay, if you're worried about these roundings affecting your answer there. All right, so that's kind of relatively straightforward, just basically finding the surface area, right, and rounding to the nearest tenth. So again, I just didn't round that one to the nearest tenth, so I'll add that into the answers later. Actually, I'll just do it now. So really, it's just surface area should actually equal 12.6 meters squared. Okay. All right, final example here. All right, let's assume we're designing party hats and we attach a piece of elastic along the diameter. How long is the elastic? And now then part B is how much paper do you actually need to make the hat? Okay, so notice in the diagram here that we've been given. We've been given the slant height of this party hat, which is clearly the shape of a cone, where the slant height is 5 inches. We actually haven't been given the radius or the diameter. We've instead been given the circumference, right? So going all the way around the bottom of the cone. So what we need to do is find, first of all, the diameter. Because the elastic is going along the diameter, we need to figure out how long that elastic's going to be. So let's go back and think about what we remember about circumference. So with circumference, here we go, right? So you might remember circumference was equal to pi times the diameter, right? So we know the circumference, we don't know the diameter. So the circumference was 22 inches. And pi is just a constant of your 3.14159, or it's a button in your calculator. So to find the diameter, right, you're doing the opposite operation here. Pi times the diameter is equal to 22. So to get the diameter by itself, since the diameter is being multiplied by pi, we'll divide both sides by pi here. Right? That will cause the pi's to cancel here, and whatever 22 inches divided by pi is, that's going to equal our diameter. So we can do that on our calculators. 22 divided by pi, and it equals 7.00 inches. Right, so it's pretty safe to say that that diameter is 7 inches across that party hat. Right, so the elastic would be 7 inches. Okay, the next part then is what is the amount of paper that you need? So again, if we're thinking about this party hat, right, in the shape of a cone, there's the pom-pom, okay? Well, obviously, if this is sitting on our heads, we don't have a flat surface here, right? The party hats go over top of your head. There's a hole in the middle here. So we don't need the circle part. We just need the around part. So we're just looking for the lateral surface area. So again, if you looked at the formula for a cone, the surface area was pi r squared plus pi rs. This part represented the circle, and this part represented the lateral area, the part going around the outside. Since we don't need the circle, we can just scratch that entire part right out of the formula, and all I'm really looking for here is just the lateral area. Right? And I actually can change that instead of being SA, LA, right? Lateral area. So in order to find how much paper we need, we just need to do pi times the radius times the slant height, right? And if we look back at the diagram again, we knew that the slant height was 5 inches, and from part A, we calculated the diameter going across the bottom here. That was 7 inches. Again, notice your formula. It's pi times the radius. This value of 7 inches is the diameter. But the relationship between radius and diameter is that radius is exactly half of that. So the radius is going to be the 7 inches divided by 2, which will be 3.5 inches. Okay? So in order to get my lateral area, it's going to equal pi times the radius of 3.5 inches times my slant height, which was 5 inches. And then I just multiply those together. Pi times 3.5 times 5. And we get 54.98 inches squared. So I think that's pretty safe to call that a nice 55 square inches are required for the party hat. Okay? All right, so that was our last example. So again, what you've got is, I think it's a set of like 8 questions, okay, for you to work on with practicing surface area of cylinders and cones. Solutions have also been posted at this point, so you can start working on those. Like I said, due to the little delay in getting this video available to you, being available on Tuesday instead of on Monday, I'll push everything back, right, which means like this was the last lesson actually for Chapter 3, so you've got some time to do some practice. I'll be posting your Chapter 3 project tomorrow, right? So your Chapter 3 unit project will come out tomorrow. So again, it'll be kind of similar to what your Chapter 2 one was, where you've got a combination of just kind of like more complex thinking questions, but also some like applications that I want you to try and do on your own, right? So it might be something along the lines of actually going to some finding a shape in your house and describing it and doing some again doing some measurements on it, just to kind of give you some of those independent things that you can just do on your own. Okay, so that's going to be your Chapter 3 project. That'll be coming at you and be uploaded tomorrow, so Wednesday, and then it won't be due until Monday. Okay, so just kind of work on these practice problems. Let me know if you have any questions. I'll help you out. The solutions are posted as well, and then just kind of work on your project. And then that's the end of Chapter 3, right? And then we'll start working on our next unit after that. All right.